We're going to solve this radical equation today. This radical equation contains two radicals. How do you solve this? We're looking for x. We're looking for the value that when you plug it into the equation, makes the equation true. Now, when you deal with radical equations, the first thing you want to do is isolate the radical. But when you have two, you need to choose one and isolate that one first. So we're going to isolate the square root of 3x minus 5 by adding this on both sides. So if we add that on both sides, we'll end up with square root of 3x minus 5 equals 2 plus square root of x plus 7. So when you add square root of x plus 7 on the left, it goes away, and when you add it on this side, it adds to the 2. All right, now that we've isolated one of the radicals, now we're going to square both sides. So we're going to take square root of 3x minus 5 and square that, because if you square square root, it makes it go away. Now this is two terms. We have a plus sign between two terms. So when you square essentially a binomial here, you're going to need parentheses. So we're going to use parentheses 2 plus square root of x plus 7 squared. Now on the left, the square root and the square, they go away, so you're just left with 3x minus 5. On the right-hand side, you're squaring a binomial. You can use the formula, or if you don't remember the formula, you could write it twice and multiply it out. So if you write it twice and multiply it out, you're essentially going to use FOIL. The left-hand side is going to stay the same, 3x minus 5. Now when I do FOIL, I do 2 times 2, which is 4. Then you're going to have 2 times square root of x plus 7. So this is going to be plus 2 square root of x plus 7. Doing the inner is going to be another 2 times square root of x plus 7. And then doing the outer, square root of x plus 7 times square root of x plus 7 is going to be square root of x plus 7 squared. All right, so the two middle terms, those are like terms. You can combine those. So I have 3x minus 5 equals 4. I'm going to combine these two terms. 2 square root of x plus 7 plus 2 square root of x plus 7 is 4 square root of x plus 7. So it's going to be plus 4 square root of x plus 7. And then this one, the square root and the square, they'll cancel each other out. And you have just x plus 7. All right, now essentially what has happened so far, we started with 2 square roots. We isolated one of the square roots, we squared both sides, and what happened was it got rid of one of the square roots. So, but we still have a square root term in here. So I'm going to have to now isolate that square root. So the goal now is to isolate this square root. So I need to get rid of this 4 on the right hand side. I need to get rid of this x and the 7. So I'm going to subtract 4 on both sides, subtract x on both sides, and subtract 7 on both sides. So I need to subtract 4, subtract 7, and subtract x. So on the left, I got 3x minus x, which is 2x. I have 5, 4, and 7. They're all negative. So you're going to add them all up. That's 16. So it's going to be minus 16. And on the right-hand side, the 4's are gone, the x's are gone, the 7's are gone. So I'm left with 4 times square root of x plus 7. Now, even though this square root is multiplying by 4, it's still considered isolated because it's, one term there. Now, one thing you should notice is that each term, 2x, 16, and 4 times square root of x plus 7, they all have a common factor of 2. So I can make the numbers a little smaller by dividing by 2 on both sides. That's going to simplify it down to x minus 8 equals 2 square root of x plus 7. All right, now that the square root is isolated and I've reduced it a little bit, now I'm going to square both sides again, like I did over here in this step. Now this is a binomial, so you're going to need parentheses when you square it. I'm going to use parentheses on the right-hand side as well, because doing the exponent rule there, you need to multiply both the 2 and the square root of x plus 7. All right, so this one, if you don't know the formula again, you could write it twice and FOIL it. X minus 8 times x minus 8. All right, on this side I'm going to square the 2 and I'm going to square the x plus 7. Squares both of them. I'm going to FOIL the left-hand side. I got x times x squared, and then I have a minus 8x, and then a plus 64. On the right-hand side, 2 squared is 4, and the square root and the square root will undo each other, so I'm just left with x plus 7 here, but it's a binomial, and then multiplied by 4, so that binomial needs to be in parentheses. All right, now you can see that I no longer have any radicals. But I do have a x squared term, which means it's quadratic. So now it's essentially solving a quadratic equation. I'm going to combine these like terms right here. That's going to be x squared minus 16x plus 64. I'm going to distribute the 4. I got 4x plus 28. And I'm going to solve this quadratic equation by factoring. What I'm going to do is I'm going to get 0 on the right-hand side. So I need to subtract 4x on both sides and subtract 28 on both sides. All right, so on the left-hand side I have x squared minus 20x plus 36 equals 0. All right, I'm going to solve this by factoring this trinomial. It's going to factor into 2 binomials. The 2 first terms are going to multiply to give x squared. That's x and x. Then I need 2 numbers that multiply to 36 but add to give negative 20. This middle term, that's going to be negative 2 and negative 18. Negative 2 plus negative 18 is negative 20, and negative 2 times negative 18 is positive 36. So this is going to factor into x minus 2, x minus 18. And then you set each of them equal to 0 and solve. If you have 2 things multiplying to give 0, that means one of them or both of them have to be 0. Adding 2 on both sides here, we get x equals 2. And adding 18 on both sides here, we get 18. Now this is solving a radical equation. The squaring step may introduce false solutions. So these may not be any good. Or they both might be good. Or one of them might be good and one of them might be bad. The only way to know for sure which one's good, or if both of them are good or both of them are bad, is to check them in the original equation. So I'm going to check each of them. Let's check the 2 first. Let's plug 2 into the original equation here. Does the 2 work? This is 3 times 2 is 6. 6 minus 5 is 1. That's square root of 1. 2 plus 7 is 9. Square root of 9. This is 1 minus 3 equals 2. That doesn't work. Negative 2 doesn't equal 2. So this 2 is no good. That doesn't mean the 18 is no good. It may be good, we have to plug the 18 in and check. So let's do the same thing. Let's plug the 18 into x of the original equation here. And see if that one works out. 3 times 18, that's 54. 54 minus 5 is 49. Square root of 49. Minus 18 plus 7 is 25. So this is square root of 25. Does that equal 2? This is 7 minus 5, which is equal to 2. And yeah, that one's working out. 2 equals 2. So this one is a yes. So I'm going to circle the 18. The 18 is good, but the 2 is no good. There you go.